Most people think artificial intelligence is changing software. You open ChatGPT, generate an image with AI, or watch increasingly advanced automation systems appear online, and the entire revolution feels digital. The conversation usually focuses on algorithms, startups, robotics, and futuristic software systems, becoming more intelligent every year. But underneath the AI boom, something much larger is beginning to happen. Because artificial intelligence does not simply require software, it requires infrastructure, and increasingly AI infrastructure is becoming so large that it is beginning to reshape America's electrical grid itself. Across the United States, utility companies, infrastructure planners, energy providers, and technology corporations are now racing to expand electrical capacity fast enough to support the explosive growth of AI data centers. Which means artificial intelligence is no longer simply a technology story. It is becoming a national infrastructure story. AI often feels abstract because users only experience the final layer of the system. You type into a chatbot and receive a response seconds later. But behind every AI interaction are giant data centers filled with thousands upon thousands of specialized processors performing enormous amounts of computation continuously around the clock. Because modern AI systems require extraordinary amounts of electricity. Training large-scale AI models can involve massive GPU clusters operating simultaneously for weeks or even months at a time. Every processor consumes power continuously. Every processor also generates heat. And as AI systems become larger, the infrastructure supporting them becomes dramatically more energy-intensive, which means electricity demand rises very quickly. And not gradually. Some modern AI data centers already consume as much electricity as entire small cities. Others are expected to consume even more as companies continue building larger AI infrastructure campuses across the country. Because the AI race is no longer just about building smarter models. It is also about building enough infrastructure to power them. And America's existing electrical grid was not originally designed for this kind of explosive computational growth. Much of the US electrical grid was built decades ago around very different patterns of energy demand. Utilities planned around homes, factories, office buildings, manufacturing zones, and predictable regional growth patterns. But hyperscale AI infrastructure changes that equation completely, because giant data center campuses can suddenly introduce massive new electricity demand into regions that were never designed to support it. And these facilities are enormous. Some hyperscale data center campuses span millions of square feet and contain huge server halls operating continuously around the clock. Inside are endless rows of processors, networking systems, cooling infrastructure, backup systems, and industrial equipment consuming extraordinary amounts of power every second of every day. Outside the buildings, giant substations, transformers, transmission infrastructure, and cooling systems surround the campuses like industrial power plants. Because in many ways, that is exactly what modern AI infrastructure is becoming. Industrial-scale energy infrastructure. And utility companies are beginning to feel the pressure. Across multiple states, utilities are already warning that future data center growth could place significant strain on existing grid infrastructure. In some regions, transmission systems designed years ago are suddenly facing projections involving huge increases in long-term electricity demand. Which means power companies now face a difficult challenge. They must expand infrastructure fast enough to support AI growth while still maintaining reliability for homes, businesses, hospitals, transportation systems, and existing industries simultaneously. And expanding grid infrastructure is not simple. Because unlike software, physical infrastructure moves slowly. Building new transmission lines can take years. New substations require planning, engineering, permits, land acquisition, environmental review, and industrial construction. Large transformers can have extremely long manufacturing lead times. Entire utility systems must be carefully balanced in order to prevent instability across regional grids. And yet, AI demand is accelerating now, which is why technology companies are increasingly competing directly for power access itself. Some companies are constructing data centers near existing energy infrastructure capable of supporting large industrial loads. Others prioritize regions with lower electricity costs, stronger transmission networks, or easier expansion potential. Places like Texas, Arizona, Virginia, and parts of the Midwest are already experiencing major data center expansion, partly because of infrastructure availability. And the scale involved is enormous. In some regions, new AI data center projects are expected to consume hundreds of megawatts of electricity continuously. In practical terms, that can rival the power consumption of major metropolitan areas, which means entire sections of America's electrical infrastructure are now being redesigned partly around future AI demand projections. And this creates another challenge, because electrical grids must constantly balance supply and demand in real time. Electricity cannot simply be stored easily at massive scale across the grid. Power generation, transmission, and consumption must remain carefully balanced continuously in order to maintain stability, which means sudden increases in industrial-scale electricity demand create complicated infrastructure problems, especially when multiple AI projects begin expanding simultaneously across the same regions. And AI infrastructure growth is happening extremely quickly, because after the rise of ChatGPT and generative AI systems, nearly every major technology company entered an aggressive infrastructure race at the same time. Microsoft, Google, Amazon, Meta, and other companies all began rapidly expanding data center capacity in order to support future AI systems. Therefore, long-term electricity demand forecasts started changing much faster than many infrastructure planners originally expected. And suddenly, energy policy conversations started changing too. Because if artificial intelligence continues expanding rapidly, the United States may need significantly more power generation capacity than previously expected, which is one reason nuclear energy discussions have started returning more aggressively into long-term infrastructure conversations. Because AI systems require stable, continuous, large-scale electricity generation, and nuclear power is uniquely capable of producing massive amounts of reliable baseload energy continuously without depending entirely on weather conditions. Therefore, some technology leaders and infrastructure planners increasingly believe future AI growth may eventually depend on expanding nuclear infrastructure again. At the same time, renewable infrastructure expansion is accelerating as well. Solar, wind, battery storage, grid modernization projects, transmission upgrades. Because the future electrical grid may need to support not only population growth and electrification trends, but also one of the largest computational infrastructure expansions in modern history. And artificial intelligence is only one part of that broader energy transition. Electric vehicles, industrial electrification, cloud infrastructure, semiconductor manufacturing, and automation systems are all increasing electricity demand simultaneously across different sectors of the economy. Which means America's electrical infrastructure is entering a new era entirely. And many people have no idea it is happening. Because from the outside, artificial intelligence still feels like software. But underneath the interfaces are giant industrial systems. Data centers, substations, cooling infrastructure, transformers, transmission lines, power plants, and enormous construction projects quietly reshaping the physical infrastructure of the country. The AI revolution is not happening only inside computers. It is happening across electrical grids, industrial zones, infrastructure corridors, and energy systems across the United States. Because artificial intelligence increasingly depends on one thing above almost everything else: power. And as AI systems continue becoming larger and more deeply integrated into modern society, America's electrical grid may become one of the most important battlegrounds in the future of artificial intelligence itself. And as artificial intelligence continues expanding across the United States, the electrical infrastructure supporting it may quietly become one of the most important industrial systems shaping the future of the country. Most people will never see these substations, transmission corridors, or data center campuses, but increasingly modern civilization depends on them. This is Civilization Underneath, new documentaries weekly.